So these are the important things, well, not important things, but these are the things that I think would be good to have on a reference sheet from 11.1. Obviously, just the idea behind it, a sequence or a series is important from 11.1. It will ask you to find the certain number of terms, or it will ask you to find the summation, which is this stuff. So we had a hard time with the actual terminology here, so I'm going to kind of try to make it a little bit easier to understand. So for the first one, when you have just a number here, right, because there's not an I, it's just a number on the right-hand side. If the bottom number is 1, then we just multiply the number on the top by the number on the front. So that if this said, let's say this was 5, this is equal to 1, and this is 2, this would be 10, because I just do 2 times 5. So you multiply out the top two numbers. And remember, it works if the bottom number is not 1, but you have to adjust the top so it gets a little shakier. This shortcut is designed when the bottom number is 1, when you start at 1. Then we got to one where there was a number being multiplied by the I. So you don't even need the A there, but let's just say this now said 2I. Now we're multiplying a number by that variable, and when that happens, you can take the number and bring it to the front, and it would be 5. The 2 can come front. I equals 1, and this would be I. And for that, which we actually learned a little bit later on the bottom here, that you can use your n times n plus 1 over 2. So when it's just the variable next to the summation, we can use n times n plus 1 over 2. So in this case, our n would be 5, because if the bottom number is 1, then the top number is our n. The 2 would still be on the front, so it would be 2 times 5 times 6 divided by 2. 2 times this is 30 divided by 2, 15. And that's 30. So if there's a number on the front of the variable, we can bring it to the front. And then we got to our sum or difference, and we could break apart our sum and difference by almost using the distributive property, but it's not the distributive property because you can't use the distributive property on summation, okay? But it is basically just telling you can break this apart. So if I had I equals 1 and I had 5 on the top and I had 2I plus 3, for example, I can break this apart into 2I plus the summation, that's a 1, of 3. And then I can do what we just did. I could bring the 2 to the front. But we already did this. 2I is the same thing that we got from up here. This would be 30. And then for the one on the right, it's just a number. So I would multiply 3 times 5, 15, and I'd get 45. Remember, if the shortcuts throw you off, you can always go back to the original, and I can plug in 1, I can plug in 2, I can plug in 3, I can plug in 4, I can plug in 5. So I would say if it's under, 5 and under, that's not so bad. But the bigger that number gets, and it is going to get bigger, the bigger that number gets, you're going to want to be able to use your shortcuts. Then came just the variable. So when it's just the variable, we do n times n plus 1, which we already did. If it's a variable squared, then we do n times n plus 1 times 2n plus 1 over 6. And if it's a variable to the third, we do n squared times n plus 1 squared over 4. So in a situation like that, again, if it was 4, maybe you're going to take 4, plug it in, you're going to do 1, then 2, then 3, then 4, and then add them all together. But if it's an I to the 10th at the top, you don't want to have to work that out. Questions on 11.1. And then obviously you had your straight up series, right? Where it would just say find the first 5 terms of this, or find the 5th term of this, and you just have to plug in the 5. Okay, then came 11.2 as your arithmetic, and remember arithmetic is adding or subtracting the same thing every time. So a simple question could just be, is it arithmetic, like in the homework? And you have to say yes or no. If it is arithmetic, then D is the common difference, what you're adding or subtracting. And there were 2 formulas from this section. The first is how do you find the equation for arithmetic, or A sub n, or ACE, whatever we want to call it, right? Which is A1 plus n minus 1 times d. And then the sum of the first n terms of an arithmetic sequence, which is n over 2, or the number of terms, over 2 times the first term in the series plus the last term. That's a really horrible A. And plus the last term in the series. And to get n, remember, if the number underneath is not 1, we do top minus bottom plus 1. So if it is 1 on the bottom, then we just say it's the top number. But if it's any other number, we do top minus bottom plus 1.
So on the test, could there be a question where it's like, is it arithmetic?
I mean, could be, sure.
And how we know it's arithmetic is if it's like...
If the same number, yep. So it could say like, is it arithmetic? If it is, find a sub n, and then you'd find the equation like that.
Okay.
Yeah. I think, we haven't finalized, but I'm pretty sure almost every question is going to be multiple choice, so that should be a little bit helpful. Which means no partial credit, but there goes the whammy. Yeah.
There's no
I think it should be
both, or
like
none of the above, or anything.
Actually, no, that makes
No,
it worse.
those
Just
are all, I
kidding. Never
read it
mind.
on test.
There is one thing when we get to the end of this section that you'll see that's like a not possible, but that's different.
But for most of
For most of it, no.
Okay.
Yeah.
So we 25%.
Just know what you're doing and then you're fine.
I know
All right,
what
chapter 11, section 3 is called Geometric Sequences. So now we're narrowing down again. We did general sequences, and then we said just arithmetic, which is adding the same thing every time. Now we're doing geometric, which is multiplying by the same term every time. So a sequence is geometric when the ratios of the consecutive numbers are the same. Meaning, I take a number, I multiply it times a number, I get to the second one. I take that number, multiply it times the same number, I get to the third one, and I keep going. So A1, A2, A3, all the way up to AN is geometric when there's a number R such that, oh, where did it go? It would be that when I did A2 over A1, it equals R. And A3 over A2 equals R. And A4 over A3 equals R. And so on and so forth. So if I took the second number, divided by the first, third by the second, fourth by the third, all of them would result in the same R.
It was also 11.2, right?
No, 11.2 would have been A2 minus A1, A3 minus A2, A4 minus A3.
What was 11.2? 11.2 was a...
11.2 is arithmetic. So you're adding or subtracting the same number each time.
Is this like the R?
Mm-mm. So R is the common ratio this time. Remember, D is the common difference. R is the common ratio. So if I took started with 2 and I multiplied it times 3, I'd get 6. Multiply 6 times 3, I get 18. Multiply 18 by 3 and I get, wait, what did I just say? 18 times 3, 54. So like that, right? If you're multiplying the same number each time.
And this is not arithmetic.
This is not arithmetic. So the same sequence cannot be arithmetic and geometric. It is either or neither. So a sequence can be arithmetic, it could be geometric, or it could be neither.
Okay. Arithmetic is like adding though, right?
Correct.
This is like multiplying.
Correct. So you want to check by saying, what's 6 divided by 2? That's 3. What's 18 divided by 6? That's 3. What's 54 divided by 18? That's 3. If it's the same number each time, then it's geometric.
What if? Okay, I actually have to clear my throat. So, like,
Oh, it's the most pathetic clearing of the throat I've ever
I
heard.
wasn't trying to be for dramatic. I thought I actually need to clear my throat. I thought it was an evil laugh. No, I really need to clear my throat. But okay, so what if there's a whole list of, I don't know, 6 numbers, and
Yeah.
you're doing the first 3, you're like, oh yeah, these are the same. Then the last one,
Then it's a no. Good question.
so we have to check every single one.
Yeah.
Okay.
Yeah. I don't know if you guys heard her from home, but what if the first 3 work, but then the 4th one doesn't work? Then it's a no. So you do want to check every one.
Will we be getting the 4-function calculator
I think we're gonna give you the for function on lockdown. Yeah. All right. Just like you have an equation for when it's arithmetic, right? So if it's arithmetic, we can find a sub n. This is how we find a sub n if it's geometric. So a sub n equals a1 times r to the n minus 1. So whatever your first term is your a1. You multiply it times that common ratio, and then you raise it to the n minus 1. And it would stay as n minus 1. So if you go back to the one we just did, what did I start with? No, I started with 2. 2, then 6, then 18, then 54. This is my a1. My r was 3 because we multiplied by 3 each time. So the a sub n of this series would be a n equals 2 times r to the n minus 1. And you have to be careful here because the mistake people make is making that 6 to the n minus 1, and that is not how it is. Only the 3 is being raised to the n minus 1. You cannot multiply that out. All right, number 1 says find the r given. The series is 1, 2, 4, 8, and 16. 2. We're multiplying by 2 each time. 2 divided by 1, 4 divided by 2, 8 divided by 4, and 16 divided by 8 are all 2. So r is 2. Homework might say determine if it's geometric. If it is, give the r. That kind of thing. Okay, 4, 12, 36, 108. Find a sub n and a 12. So first, what's the r? 3, right? 12 divided by 4, 36 divided by 12, 108 divided by 36. So r is 3. Now I got to find the equation for a n. So a n equals the first term, which is 4, times the r, which is 3, raised to the n minus 1. So that's the first part.
Is this a n to the what?
A, comma.
Oh.
Yeah, that's a comma. And then it says find a10.
This is like the biggest number.
Yeah, they're going to be big.
Uh,
3 to the 10. This is why you might get a calculator. I don't know if they won't necessarily be that big without a calculator, but it's a trade-off. All right, so I'm going to do 3 to the 9th. I'm not going to multiply that. I'm going to use the calculator. 3 to the 9th, which is 19,683.
Let me see.
I mean, it grows exponentially, right? So it happens fast. 78,732 would be the 10th term.
What? What is this? Oh, right, you have to multiply. Oh,
3 to the 9th times 4.
I disapprove.
Your disapproval has been noted. Okay, 3, 12, negative 4 thirds, negative 4 ninths. Again, find r and find a sub n. So my r this time is what? Negative 1/3. So, oh, that should be positive. Sorry, that's that left. Or did we intend for it to be a no? Hang on.
Yeah.
That may be so long ago. Not no solution, it just wouldn't be right.
No.
I think that's a typo. I don't think.
No, I think it's
Hang on. What happens when you type notes out and then do them a week later? Where'd it go? Okay, change that to a positive. It's even wrong on the notes, but then it has an answer, so that's not right. All right, so we're going to change it to positive. Then it's alternating signs, which means there's a negative involved, right? So negative 4 divided by 12, and then positive 4 thirds divided by negative 4. All of this is going to result in 1/3, negative 1/3 being your r.
Oh, right.
So then my a n equals the first number, which is 12, times the r, which is negative 1/3 to the n minus 1. Your r can obviously be a whole number. It could be a fraction. It could be a decimal. It could be a positive. It could be a negative. It's still arithmetic.
Oh, wait, that's the.
Okay, then 4, find r a1 for a sub 3 equals 20 and a sub 6 equals 160. So here's the thing, we don't have first and we don't have the next one to figure out what r is, right? And this is not arithmetic where you can add up the tops and divide by the changes. Like you can't do it the same way we did arithmetic. So this is how we do geometric. You're going to take the bigger base of the two that you have. So I have A3 and I have A6. I'm going to take the one with the bigger base, which is 6, and I'm going to put it on the left. So A6 would equal, I'm going to do A3, and then I do R, and I need the exponent on the R to be the difference between those two bases. So 6 minus 3 is 3. So if it doesn't give you the first, or you don't have consecutive ones to find your R, that's how you do it. You would do A bigger base equals A smaller base, R, and then the difference between those two. So let's say I was given A3 and I was given A10. What's my equation going to look like? Which is? Nope. Hashtag 7. The difference between, I actually need a number there. The difference between those two numbers, which would be 7. Okay, so I get A6 right on the left, which now I have a value for. That's 160. Equals A3 on the right, which is 20. R to the third. How do I solve for R? Divide both sides by 20. So if I was given, that's a separate example, not the one we're doing. So it was like a hypothetical example.
Okay.
Yeah, not related to the one we're doing.
So that I didn't know what you were talking
Yeah, no. So this would be R to the third equals, this cancels, I get 8. And then it's not a square root, it's a cube root. So I got a cube root, a cube, not a square. I got a cube root both sides. And the cube root of 8 is 2. No, because it's a cube root, it would say the true sign. Now, here's one option. Go from A to the third, divide by 2, divide by 2, divide by 2 to move it back to the 1, right? Or set up a new equation with these two. So A to the third would be on the left because that's the bigger base, equals A1, R, what would the exponent on the R be? 2. So the 3 I know is 20. The A1 is what I don't know. R is 2 squared. 20 equals A1 times 4. And I get A1 equals 5. Again, I could have taken that A3, 20, divided by 2, that's 10, divided by 2, that's 5. I could have moved it back 2 places doing that too. So here's my A1, and here's my R.
We have to finish part of this tomorrow.
Yeah, well, we're going to go. Yeah. Because next is the summation, right? I have one more, and then I think I'll stop at the summation. We good so far?
What did you get the equation for like A3 equals A1 R squared?
So if you don't have consecutive, that's what we do, which is this thing I wrote kind of up here. If you don't have consecutive terms where you could find R, then you want to do it that way.
Okay.
You either don't have consecutive terms or you don't have A1. Then you put A with the bigger base on the left, A with the smaller base on the right, and then R raised to the difference between those two.
No, not that one.
Oh.
Like, oh. So
I just
R
used it
squared
twice.
is the difference. Okay.
Right, I just used it
That's
twice.
Okay.
Yeah.
That makes sense now.
I think those are the hardest ones. I mean, there's something in summation that gets tedious, but that's like the hardest concept. All right, so the A9 goes on the left. Then A4 on the right, what's the exponent on the R have to be? 5, good. So negative 1 over 128 equals negative 1/4 R to the 5th.
Why is it 5? Isn't it n minus 1?
Right, but the bottom is 1. So if I want to find an, it's a1 r to the n minus 1, right? So if I want to find a3, it'd be a1 r to the 3 minus 1, which simplifies to 2. These two will always add up to that one. We just don't use a1, we use whatever we've got.
So just ignore the n minus 1.
When you find a sub n, like the formula, you'll always keep it n minus 1 as the exponent. But when you don't have consecutive to find r and you're trying to find the r the way we're doing it, you ignore the minus 1. You just want to make sure they add up. Yeah. All right, so now I'm going to multiply both sides by a -4 to get rid of that -1/4. This is 32, so I get r to the 5th equals 1 over 32. And then I want to find the 5th root of 132. 5th root of 1 is 1. 5th root of 32 is 2. There's my r.
So hypothetically, let's just say you did not multiply by,
What'd you do?
I don't know what I did.
Divided by a 4th, same thing as multiplying by
Oh,
4.
I did it wrong and then just got 32.
Oh, just be careful.
Are they gonna always like equal out?
Yeah, if it's a root, well, I mean, in general, in the world of summations, in series, they might not, like you might have a decimal there,
Yeah.
but in here, they'll go evenly.
Oh.
Yeah. All right, so now I want to find a1. So I can use a9 or I could use a4. If I use a9, then my r's got to be raised to the 8th. If I use a4, then my r only has to be raised to the 3rd. Again, you could use either one, but obviously the closer to a1, the better, because the smaller your r's end up having to be. So a4 is 1/4, a1 is what I don't know, r is 1/2 raised to the 3rd power. 1/4 equals a1, 1/2 raised to the 3rd power is 1/8. Multiply both sides by 8, cancels from here, and a1 equals 4, goes into 8 twice. A1 is 2.
Is it -2?
Yes, sorry, this is a -1/4, so -2. Thanks, Sophia. So it didn't ask for it, but if I had just been asked for an here, once I got a1, I'd get -2. My r, which is 1/2, raised to the n minus 1. So again, it didn't ask for it that time, but just be prepared that if it does, that's how I want to set up my equation. Questions? Okay, so I'm going to stop here, and we're going to pick up with the summation formulas tomorrow. The web assign is published, and if you want to start it, you can feel free to start it today, or you could do it tomorrow. You get all the way through the summations, which I think is like the last 2 or 3 problems. So you can get all the way through anything that has a series in it. As soon as you see the little sigma, that's when you can stop.